For homeowners, a wet basement is a major problem. Water in the basement can cause damage to carpets, woodwork, drywall, or stored items. Worse yet, the molds and mildew that can hide behind the walls and beneath the carpet can be carried through the ventilation system to all areas of the house, causing or exacerbating health issues. Water control systems can protect not only the value of your home, but also the health of your family. There are many ways that water can enter a basement. Understanding how the water enters a basement is crucial to determining the proper solution to the problem. Rain and groundwater are the most common causes of basement water. If you live in a 2,000 square foot house, roughly 1,250 gallons of water will fall on your roof if it rains just 1 inch. If you have any issues with your gutters and downspouts or the soil grading around your home's foundation, that water can very easily find its way into your foundation and your basement. Once the water has found its way to your foundation, there are a number of mechanisms that draw water through your foundation walls and into the basement. Concrete is porous and allows for capillary action. Ever put the corner of a paper towel into some water and watch the water climb up the towel? Concrete walls do the same thing with water trapped in the soil around your home. Depending on the type of soil you have, this capillary action can pull water into your foundation from as far as 20 feet away. There's also the issue of air pressure. In most houses, there is a slight negative air pressure in the basement. This is caused by a stack effect, which happens when air warms in the basement and rises to the upper level of the house. This negative pressure in the basement can be enough to draw moist air in through any cracks or gaps in the foundation or through uncovered sump basins. If the home is on a block foundation, moist air can even come through the block cores themselves. Make sure gutters and downspouts are clean and functioning properly. A minimum of 1 downspout per 50 linear foot of roof eave is recommended. Make sure that downspout extensions extend at least 4 feet away from the foundation wall. Also make sure that the soil around the foundation is sloped away from the house. 1 inch per foot of slope is recommended for at least 6 feet away from the house. If you already have a sump system, make sure the pump is functioning properly and the drain tile hasn't collapsed due to soil weight or become obstructed due to tree roots. In some instances, a little maintenance is all that's needed to take care of a small water problem. If those maintenance steps don't solve the problem, a drainage system will be the next step. There are a few varieties of drainage system to consider. The single most effective solution to basement water is an exterior drain tile system. An exterior system uses a membrane to seal the wall from moisture from the outside and directs water into a drainage field and sump system to pump water away from the foundation walls. Though very effective at controlling basement water, an exterior drainage system is very costly and requires major excavation around the entire foundation, which for most homes means that shrubs, gardens, decks, steps, sidewalks, and other landscaping have to be removed and reinstalled after the system is in place. For most homeowners, the high cost and major disruption of an exterior system outweigh the benefits. There are also interior drainage systems. Some homeowners choose to install a drainage channel above the concrete slab in their basement. This is the simplest and least costly type of drainage system and may be effective for poured concrete walls where cracking is the main point of entry for water. However, this does not solve the problem in block walls, because water will continue to pool in the block cores. The water level cannot drop below the level of the slab. Also, there is still the potential for efflorescence or mold and mildew on the walls themselves. Another type of interior drainage system places a drainage channel in the edge of the slab on top of the footing. Holes are drilled into the base of the block, and the water is moved to a sump basin through the drainage channel. These systems facilitate block drainage, which makes them an improvement on an above-slab channel. However, this system is still less than ideal, in part because it requires an open gap between the floor and wall, allowing soil gases such as radon, damp odors, and even bugs to creep into your basement. The small size of the drainage channel makes it more prone to sediment blockage, and it can even be overtaken by water flow during heavy rains, leading to more leaking. Plus, the foundation blocks are sitting in water, allowing moisture to be wicked up into the wall, which can damage drywall or, worse yet, leave you with a mold problem behind your walls. The most effective interior drainage system is a sub-slab rigid drain tile system. By placing the drain tile alongside the footing, water is allowed to drain to a level beneath the slab. Like the smaller drainage channel system, holes are drilled in the bottom course of the block wall, allowing water in the block to drain completely into the drain tile. Getting the water across the footing and into the drainage field is one of the biggest challenges to installing one of these systems. In the past, contractors have used several methods to move water across the footing. Some installed small tubes from the block to the drainage field. These are prone to sediment blockage and also make it hard to replace the concrete floor to the same thickness as the original slab. Other contractors installed washed rock on top of the footing, which isn't prone to blockage, but again doesn't allow the contractor to replace the concrete to the original thickness. Dimpled sheeting is another option, which seems to offer the best compromise between water flow and concrete integrity. It allows unrestricted flow and allows for concrete replacement at the original thickness. However, the dimpled sheeting requires an open gap between the floor and wall, just like the drainage channel system. Once the water has moved across the footing and into the drainage field, it finds its way into the drain tile. Even here, there are issues that need to be addressed. Oftentimes, contractors use flexible corrugated plastic piping with access slots cut in to allow water into the drain tile. There are several problems with this product. Due to the corrugations, a quarter-inch of water can stay in the tile after the rest is drained into the sump basket, potentially leading to damp odors and other problems. And because the pipe is flexible, it is extremely difficult to maintain a consistent downward slope to the sump, causing water to pool in the low spots. Also, since the pipe material isn't rigid, it can collapse or be crushed under the weight of the drainage media and concrete. In most cases, Standard Water Control Systems is called on to install interior drain tile systems. We install a below-slab rigid PVC drain tile system that includes a sump basin with our service-marked diamond plate cover that is bolted airtight to the top of the sump basin. We developed our patented diamond drainage board, which allows for unrestricted water flow, allows our crews to patch the concrete to the same thickness as the original slab, and solves the issue of an open gap between the floor and wall. Of course, you should consult with a professional to find out if a drain tile system will fit your needs. Standard Water's experienced staff can give your home a professional evaluation and help you make the right decision for you and your family.